Protein powder has become one of the most widely consumed nutrition products on Earth, used by athletes, bodybuilders, medical patients, and everyday consumers looking for convenient protein intake. Yet behind every scoop is a vast industrial process involving agriculture, chemical separation, filtration technology, massive drying towers, precision blending, laboratory testing, and high-speed packaging lines. What looks like a fine flavored powder inside a plastic tub is actually the final stage of a tightly controlled food engineering system designed to deliver consistent nutrition, safety, taste, and shelf stability at enormous scale. And today on the How Factory, we're going inside modern protein powder manufacturing facilities to see exactly how protein powder is made, from raw ingredients to the final sealed tub shipped worldwide. The journey begins with the protein source itself. For whey protein, the most common type, production starts in dairy processing plants. Raw milk arrives from farms in refrigerated tanker trucks and is immediately tested for fat content, protein levels, antibiotics, and microbial safety. After approval, the milk is pasteurized and separated into cream and skim milk. During cheese production, enzymes are added to coagulate milk proteins into curds. What remains is liquid whey. Once considered waste, now one of the most valuable raw materials in sports nutrition. This whey is mostly water, but it contains lactose, minerals, and dissolved proteins that must be concentrated and purified. For plant-based protein powders, the starting point looks very different. Ingredients such as peas, soybeans, rice, or oats arrive at processing plants in bulk. These crops are cleaned using vibrating screens, air separators, and magnets to remove dirt, stones, and metal fragments. The clean raw material is then milled into flour and mixed with water to form a slurry. Mechanical separators and centrifuges remove fiber and starch, isolating the protein-rich fraction. Whether dairy-based or plant-based, the next goal is the same: separating protein from everything else. This separation happens using advanced filtration systems. Large stainless steel membrane units perform microfiltration and ultrafiltration, forcing liquid protein through extremely fine filters. These membranes allow water, sugars, and small molecules to pass through while trapping protein molecules. Pumps continuously circulate the liquid through multiple filtration stages, gradually increasing protein concentration. For whey protein isolate, which contains very little lactose or fat, additional filtration passes are required. Sensors monitor flow rate, pressure, temperature, and protein concentration in real time. Any deviation can affect purity or efficiency, so the process is tightly controlled. Once the protein is sufficiently concentrated, it exists as a thick liquid. But protein powder must be dry, stable, and shelf-ready, which brings the process to one of the most dramatic stages: spray drying. The liquid protein is pumped into towering spray drying chambers that can reach several stories high. Inside, high-pressure nozzles atomize the liquid into millions of tiny droplets. Hot, filtered air rushes through the chamber, instantly evaporating moisture. In seconds, liquid protein becomes fine powder. Temperature control here is critical. Too hot and the protein denatures. Too cool and moisture remains. Cyclone separators collect the dried powder while removing fine particles from the airstream. The freshly dried protein powder is transferred through enclosed pipelines to storage silos. These rooms are climate-controlled to prevent moisture absorption, because protein powder is highly hygroscopic. At this stage, the powder is unflavored and nutritionally pure but not yet ready for consumers. Before moving on, samples are sent to on-site laboratories where technicians test protein percentage, moisture content, microbiological safety, and amino acid profile. Only approved batches are released for formulation. Next comes blending, the stage where protein powder becomes a finished consumer product. In large blending halls, stainless steel ribbon blenders or paddle mixers combine base protein powder with flavor systems and functional ingredients. Depending on the product, these additions may include cocoa powder, vanilla compounds, sweeteners, vitamins, minerals, enzymes, electrolytes, or thickening agents. Each ingredient is weighed with high precision, often using automated dosing systems connected to formulation software. Even small errors could affect flavor or nutritional accuracy. Blending must be thorough but gentle. Overmixing can damage fragile ingredients or alter particle size, while undermixing leads to inconsistent taste and nutrition. Mixing times, blade speeds, and batch sizes are carefully calibrated. Quality teams pull samples from multiple points inside the blender to confirm uniformity. Every scoop from the final product must contain the same protein content and flavor intensity. Flavor development plays a major role at this stage. Protein on its own can taste bitter or chalky, so food scientists design flavor systems specifically to mask off notes while maintaining stability over months of storage. Flavors must survive humidity, oxygen exposure, and temperature changes without breaking down. Sweeteners are chosen based on solubility, sweetness profile, and consumer preference. Extensive sensory testing ensures that the finished powder dissolves smoothly and tastes consistent from batch to batch. Once blended, the powder undergoes another round of quality control. Laboratories test protein concentration, moisture level, solubility, density, and flow characteristics. Microbial tests confirm the absence of harmful bacteria, yeast, or mold. Heavy metal screening ensures compliance with food safety regulations. If any parameter falls outside specification, the batch is quarantined for investigation or reprocessing. After approval, the powder moves to packaging, one of the fastest stages in the facility. Packaging areas are kept under controlled air conditions to prevent contamination. Empty plastic tubs arrive on conveyors and pass through air blast cleaning stations that remove dust and static. Automated auger fillers or weight-based dosing machines dispense exact amounts of powder into each container at high speed. These machines can fill dozens of tubs per minute with accuracy measured in grams. Before sealing, many tubs receive desiccant packets to absorb moisture and extend shelf life. Foil induction sealers heat bond protective liners to the tub rim, creating an airtight barrier. Lids are then applied and torqued to specification. Tamper-evident bands or seals ensure product integrity for consumers. Each filled container passes over a check weigher that confirms correct fill weight. Any underfilled or overfilled tub is automatically rejected. Labeling follows immediately. High-speed labelers apply branded labels that include nutrition facts, ingredient lists, allergen warnings, batch numbers, and expiration dates. Vision systems inspect label placement and print clarity. Inkjet or laser coders mark each tub with traceability codes, allowing manufacturers to track every unit back to its production run. Next comes secondary packaging. Automated case packers group tubs into cardboard boxes which are sealed and labeled for shipping. Robotic palletizers stack boxes into stable pallets optimized for transport efficiency. Pallets are stretch-wrapped and logged into warehouse systems that track inventory in real time. From here, products move to distribution centers, retailers, gyms, hospitals, or direct-to-consumer fulfillment hubs. Behind the scenes, sanitation and hygiene never stop. Protein powder facilities operate under strict food manufacturing standards, similar to pharmaceutical plants. Equipment is cleaned using clean-in-place systems that flush pipes, blenders, and dryers with hot water and sanitizing solutions. Air filtration systems maintain clean environments in blending and packaging zones. Employees wear protective clothing and follow strict handling procedures to prevent contamination. Sustainability is increasingly important in modern protein manufacturing. Many facilities recycle water used in filtration processes. Energy-efficient spray dryers reduce fuel consumption. Waste heat is captured and reused. Packaging is redesigned to reduce plastic use or improve recyclability. Plant-based proteins continue to grow in popularity as manufacturers seek lower environmental impact and diversified sourcing. What makes protein powder manufacturing remarkable is how it transforms raw agricultural materials into precise nutritional products. Whether derived from milk or plants, protein must be isolated, purified, dried, blended, tested, and protected with extreme care. The final product must deliver exact nutrition, dissolve smoothly, taste consistent, and remain stable for months, all while being produced at massive scale. From liquid whey or milled crops to fine powder sealed inside a tub, the journey involves kilometers of stainless steel piping, advanced filtration membranes, towering spray dryers, laboratory testing, and robotic packaging lines. Every scoop represents hours of processing and countless quality checks hidden behind a simple container. And that is exactly how protein powder is filtered, dried, blended, flavored, tested, sealed, and packaged. A sophisticated fusion of food science, chemical engineering, and industrial automation, powering one of the world's most popular nutritional products. Thanks for watching The How Factory, where we reveal how the world really works. Don't forget to like, subscribe, and join us again for more deep dives into the machines, systems, and factories behind everyday products.